So now let's take a look at example 2 where we're going to find the Maclaurin polynomial for sine of x. Again, anytime you see that phrase sine of Maclaurin polynomial, we know that we're looking at a center at x equals 0. And you can see by this diagram, this is where my sine of x curve is compared to my Maclaurin polynomials. So first of all, we know that my function is sine of x. And again, my center is at x equals 0, and I know sine of 0 is 0. So when I write a Maclaurin polynomial, the formula is going to be f of 0 plus f prime of 0 times x plus f to the second derivative of 0 times x squared over 2 factorial plus f to the third of 0 times x to the third over 3 factorial plus dot 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 plus your f to the nth of 0, x to the nth over n factorial. So we want to take this out, since it's not being specific what degree or how many polynomials, we're going to take it out to at least 3. So first of all, I want to find the derivative of sine, and I know the derivative of sine is a cosine x. So then I want to find f prime of 0, and I know cosine of 0 is 1. So now remember, when you're doing your derivative of sine and cosine, your SCSC chart, remember SC, SCS, and again, these two are negative. And when I go down, this will help you remember your derivative signs. So then when I find the second derivative for sine of x, I'm going to take the derivative of cosine, which is just going to be negative sine. So then the second derivative of 0, plug in 0, no sine of 0, 0. Third derivative, the derivative of negative sine is going to be a negative cosine x. And then the third derivative at 0 is going to be negative 1. Fourth derivative, the derivative of negative cosine is going to be a sine x. And then I know that the fourth derivative of sine, the fourth derivative of 0, sine of 0 is just 0. I'll do one more. Derivative of sine is a cosine x, and then the fifth derivative is going to be a 1. So now if you notice what's going to end up happening, some of these polynomials are actually, some of these terms are actually going to cancel out because the value of the derivative is actually 0. So when I go to write my Maclaurin polynomial, f of 0 is going to be 0 plus f prime of 0 times x, I found f prime of 0 to be 1, so it's going to be a 1x, plus the second derivative at 0 is going to be 0, x squared over 2 factorial, plus the third derivative is negative 1, so this will be a negative x to the third over 3 factorial, plus the fourth derivative at 0 is going to be 0 times x to the fourth over 4 factorial, and then finally one more will be plus x to the fifth, 1 times x to the fifth over 5 factorial, plus your nth term. So let's see what we end up happening. So again, these terms ends up happening, so we're left with, notice, an x, because this cancels, and this cancels. So we're left with x minus x to the third over 3 factorial plus x to the fifth over 5 factorial. We want to show at least 3 terms in your polynomials if they're not specific about the degree. So plus dot dot dot, remember polynomials have a definite end. So your general term, notice you've got an alternating terms. So I'm going to have to put the alternator, and again, I'm starting when n is equal to 0, so this is going to be negative 1 to the n. Now, in order to get these terms, when you're dealing with a Maclaurin polynomial and you see that the even terms are canceling out and you're left with just the odd terms, the exponent will be a 2n plus 1. If it's even, it's going to be just a 2n. So to come up with my general term, it's going to be an x raised to the 2n plus 1 all over 2n plus 1 factorial. So if this is my 0th term, this is my first term, you'll see that you'll generate each individual term. So there is your Maclaurin polynomial for sine. So now my next term is cosine x. So now you can see in the diagram that here is my graph for cosine x. And you can see how these different functions, the more polynomials I put on, the more generalization it's going to end, the convergence of the two graphs. So again, my Maclaurin polynomial for cosine, again, I'm going to start with f of 0 plus f prime of 0 times x plus the second derivative of 0 times x squared over 2 factorial plus f to the third of 0 times x to the third over 3 factorial. So notice when I have my function as cosine x, f of 0 is going to be 1, because cosine of 0 is 1. So f prime of x. So cosine, the derivative of cosine x is going to be a negative sine x. And f prime of 0 is going to be 0. So the second derivative is going to be the derivative of negative sine, which is going to be a negative cosine x. And the value of the second derivative, cosine 0, is going to be a negative 1. So the third derivative, the derivative of negative cosine, is going to be sine x. So the third derivative for sine, the value of the third derivative is going to be 0. So you can see the difference. Notice what's going to end up happening. The odd terms are going to cancel out, and the even ones are going to remain. So my Maclaurin polynomial for cosine x, f of 0 is 1, plus f prime of 0 times x is going to be a 0x. The second derivative at 0 is going to be a negative 1, so that'll be a negative x squared over 2 factorial. The third derivative is going to cancel. And if I was to take this out one more time, the derivative of sine is going to be a cosine x, and the fourth derivative at 0 is going to be 1. So this would be a plus 1x to the fourth over 4 factorial.